guys, my name is Taj from the Wingineers, and here's how we design our product. So we were put into the biomedical group for our project, so we wanted to do something that could help the medical community. So a big issue that we all came up with was the overcrowding in hospitals. So what we thought was we wanted to find a way to get people out of hospitals quicker so we can create more space in them. So we took something simple like taking someone's temperature, and we decided to try inputting that data into a Raspberry Pi and trying to send that signal to a server at the hospital so that the hospital could receive that data from the patient. So what we did was we considered a patient going home, say right after a surgery, going home from the hospital, and what they would do is they would take this Raspberry Pi and it would be connected with a temperature sensor, and they put that temperature sensor into their mouth. And what that would do is that would get their temperature put onto the Raspberry Pi, and then the Raspberry Pi could send that to the hospital server right from the person's bed. And it can always, if we give it one function, it can continually repeat it, and it's a really small product, so this can enable people to carry it in their purses, in their bags, wherever they are, so they can take their temperature at any time the doctor wants by just holding this device.
Okay, we came up with this idea. There are already ideas, things out here that exist for temperature connectors connecting to Raspberry Pi. Those things already exist. What we're inventing is the part where you can send that information from the Raspberry Pi to a server, to a hospital. We think it can be very useful, and it can be very widely applied throughout the larger American hospital system.
So now we chose temperature because it's one of the biggest things patients have to deal with after surgery. You always have a higher body temperature because of dealing with infections and dealing with the side effects of surgeries. So we figured that if we could continually monitor this big asset, that we could do the hospital's amazing deed, and we can help the patients get out more easily. So in the future, along with this product taking a person's temperature, we hope to have it take the person's blood pressure to see how much oxygen is in their blood, to take EKG measures, and things like this, so we can continually send all the information the doctors need straight to them, and we can get the patients out of the hospital sooner. We hope that we can create a big effect with this, so that with our networking with the hospitals, they can give all these patients our product, and they can all go home earlier, and the hospitals can set up mass servers that can input all the patient's information. And if we want to make this a wide-scale operation, we can spread it throughout the U.S., throughout the world. It all depends on how much investing in.
All right, Michael here from the Wingineers. All things you have to pay for in order to make this thing. It's not everything we're going to be using to manufacture the product. It's simply all the stuff we had to use to code and to set up our device. First thing we bought was the Raspberry Pi kit. This included all the stuff that the other groups got in the biomedical group, all the wiring, the breadboard, all the resistors the other groups got. Next, we bought our thermal probe. This probe works well with our computer we bought. We bought a Raspberry Pi version 2. This Raspberry Pi has capability for HDMI, Bluetooth, wireless connectivity, connection to the internet, and that's something going to come in handy later. This thermal probe works really well with this. We were able to use code that was already existed, as well as make some of our own code to put into this Raspberry Pi 2 to program this thermal probe. The next thing we kind of borrowed was an HDMI cable. This cable was brought from one of our TVs at home. This is something that we're going to return back to the person who lent it to us. However, it was essential for allowing it to code, because the Raspberry Pi 2 is essentially a little computer, and in order to view what's going on in it, you have to have a monitor, and we used the HDMI cable to connect the little computer to the monitor. Next thing we used was the USB 2.0 charger. This is how we powered our Raspberry Pi, our little computer. Again, we borrowed it. It's actually mine. We plugged into an outlet, runs 120 volt AC into the Raspberry Pi version 2, and lets it run. The next two things we borrowed were a Dell mouse and keyboard. We take these every time we want to code the Raspberry Pi from our computer in the classroom. We have a couple computers in there, and we unhook the USBs from there. We plug it into the Raspberry Pi. It allows us to code, browse the internet, and do everything Raspberry Pi can do. Next, we use 2 feet of ABS plastic. We have 2 3D printers in the school, and we used one of them to print out our case. What we borrowed were wire cutters. Wire cutters are very common in our school. We have a robotics club here, so we borrowed them from there. We use the wire cutters to strip some of the wires. That way we can solder them, and right now they're temporarily attached. However, we're going to do a permanent solder later. The last thing to borrow was a spectrometer. This is something that actually existed with the video game club at our school. However, we borrowed it from them, so that way we could see what's going on our device, code it, and do other things as well, browse the internet, connect to Bluetooth, all that stuff. And the final thing that we used to make was a reused home thermometer. It's something we actually ended up destroying in the process of creating. However, we thought that we could maybe use it, take the circuit from it, and actually use that to connect to a Raspberry Pi and connect that to the hospital. However, after taking that part of the circuit, we actually ended up permanently destroying it in the process. But it was a very useful process because it allowed us to realize we had to buy the thermal probe, as well as realize that how to code this very efficiently and effectively, because we tried. All right, Mike here from the Engineers. Here we're going to go over the cost to manufacture our product. It's significantly less because all the research and development we had to do and all of the actual stuff we need to make it is less than all the stuff we had to buy. This here, $35 Raspberry Pi version 2, something we borrowed in the prototype version. However, in the actual first version of it, it's going to probably cost us a good amount of money. That being said, when you buy one Raspberry Pi as opposed to buying, a couple thousand, the price is significantly going to go down. I looked up online; it costs them about $2 to make it, so they're making a very hefty margin. We probably negotiate a contract with people who make Raspberry Pi to get it significantly down. Copper wires, we need 6 of them in our prototype. We bought them as part of our kit. We're approximating this cost to be $5. However, it could be much less than that, it could be much more than that. We think that $5 is a safe estimate, and it could in fact be much lower, especially with vertical integration, especially mass production. Thermal probe, $7, something we had to buy and ship from China. Mass produce them, we can significantly reduce that cost. And the final thing is 2 feet of ABS plastic. ABS plastic and 3D printing in general is very inefficient. It's great for prototyping, it's great for doing stuff immediately, however it's not great for making many different versions of things. When we start making a case, we're going to make our plastic out of molds, and that'll significantly reduce the cost. And you see here the total cost right now is $52. However, we think that's going to drop to less than $10 with vertical integration. Vertical integration is a manufacturing technique pioneered with guys like Edison to make everything you need for a product in-house. It's not, you don't outsource products, you don't buy products, buy something from here, buy something from here, make everything in the same building. It allows cost to go way down. And the final thing we're going to use to reduce cost is mass production. So when we start buying or we start making Raspberry Pis here in America, the cost is going to go significantly down. To do that, and we estimate it'll go less than $5, considering they make it now currently in China for approximately $2. And with this new price of $10, we're looking to sell to the hospital for $15. And even at the price tag of $52, we're looking to sell to the hospital for $15 in order to saturate the market and get as much usage as possible. Somehow we need to use our ton of energy to power our device and to make it work. That even though it would be very impractical, we're going to be attaching a solar panel to the case of our device. That way it could power it and allow it to connect to the hospital server and take temperature. We don't think this would work. It's not going to work on our prototype. This is my prediction going to the future. In order to have solar panel power, it have to be somewhere in the range of 10 to 15 times more powerful and efficient in terms of getting energy from the sun. Other devices such as wind turbines make very little sense on this device. That being said, I don't see renewable energy as something that is done from product to product, device to device. Renewable energy has to be something that's done on a large scale from the government. So instead of having solar panels power our device individually, it makes much more sense to have solar panels power the electricity that comes out of the outlets, the 120 volt AC that comes out. If any of these little devices and any of these little
solar panels or wind turbines you throw onto any technology or any electronic device is something that, in my opinion, slows down progress and is ultimately something that will reverse and make progress go backwards and have people get a negative connotation, a negative idea of what renewable energy and alternative energy could be. Okay, so we were inspired by Thomas Edison. You know, this is the project that bears his name. We think he's a great guy. He's a great inventor. He's didn't really care what people thought of him. Other things we adopted from him are his ability to question everything. We spent many weeks questioning the modern biomedical practices and standards of the time, and we think this is the best solution to the problem. So, all right, so we used very little recycled materials in this product. Figured we would just buy new stuff. Also, we had a $75 spending budget, and all our stuff fit inside that budget, so we figured, why not buy new things? That being said, we did use some recycled thermometer. We broke it though in the process of trying to prototype it, and we think that was very valuable. But however, in any emerging new technology field, we think that recyclable, renewable product is something that's not really a thing, and we wanted to make things easier for ourselves and not harder for ourselves. That's why we bought new stuff instead of reusing old stuff.